Hello, welcome back. Take a look at the problem. In this problem, we would like to find out the compression load in member BG due to a right side of the load of the vehicle crossing this bridge, crossing this truss. The load you see here, it's already been divided by 2. So, and it's a good looking vehicle, you gotta admit that. I did it myself. So, excuse me. Now you have on a front wheel you got 1.5 kilonewton, second wheel 4 kilonewton, and back wheel you got 2 kilonewton. As this vehicle going across the truss, what is the maximum compression load on BG? You remember the last video I just put on, we learned how to do the influence line. So if you don't know, I recommend you should watch that one. But how did we get this? We need this to calculate the maximum compression load in BG. We did this before, and I'm going to just go over it quickly. If we take a look at this whole truss, and then we load it with the 1 unit load. So if I put 1 unit load here, and I can calculate AY, then I'm going to cut the truss in half, use a method of a section, and I can calculate this member force in BG. Then I will write it down, and that will become at 0. When my force is at 0, this member comes out 0 when I have to do the calculation. Then I go ahead and move my unit load right here at point B. And then I calculate the reaction AY, and then I will go back and calculate my member BG, which come out to 0.312. Move on again, put 1 unit load here, calculate AY, I calculate my member BG. In here, same thing, in here, same thing, and that's how we came up with this. And there's a good example in a previous video, take a look at that. So now we have that. We're gonna go ahead and move this across the bridge, and we wanna find out where's the maximum. One of the first things we're gonna do is say, it's just basically a trial and error, see which way you're gonna give us the maximum. First, let's put the first front wheel on top of the C right here, because you need the whole vehicle to be inside of the truss to make a bigger impact. So if I put the front vehicle up here on top of the C, it would be like, let's do like a free body diagram. If I put a 1, it'd be put a 1.5 kilonewton right here. And then the next wheel, the next load, which is 4 kilonewton, is going to be 2 meters away. And 2 meters is going to be right here. And that's going to be my 4 kilonewton. And my next wheel is about 3 meters away, so that's 1, 2, 3. It's going to be right here, which is about 1 meter away, and that's going to be 2 kilonewton. All right. So now when you look at this and line this up with the influence line, and we're going to go ahead and try to calculate the maximum moment due to this. So we're going to say if the maximum moment for FBG is, it's going to be, let's start off from where we started with the front wheel. It's going to be 1.5. Right here it's going to be 1.5 multiplied by negative 0.625. And then we are going to have the 4 kilonewton, and that's going to be right there, which is where we're 0 at 4. So it's going to be plus 4 times 0. Then the next one is a 2 kilonewton. So plus 2 kilonewton time, and the slope of this is 0.3 rise over run, so it's 0.3125 divided by 3. And because only 1 foot away, we're going to be right here 1 foot away, multiplied by 1 equals 0. That's a positive, that's a negative, and that comes out to, I think I did it right, calculated it. Minus 0.729. So equal minus 0.729, and that's a kilonewton. So that was the first scenario which we put the load were on there. So we're going to come in and say, okay, we did a first trial, and load was, the front wheel was on at point C. At C, and we came out to minus 729 kilonewton. So this is, let's go ahead and move the vehicle further on. What if now this second wheel right here goes at point C? All right. So if the second wheel go on point C, okay, middle wheel at point C, and let's do this again so we know how it's looking. All right, now the second wheel is 4 kilonewton. It's going to be at point C. We got 4 kilonewton here. And the front wheel is going to be 2 meters away. It's going to be, so at point 8 right here. So that's going to be 8 feet away. And that's going to be 1.5. And the last wheel, it's going to be 3 meters away. So that's a 6 going to be right here and right on 3. And that's going to be 2 kilonewton. Makes it easier now when you draw it like this and you compare it to influence line. So you're going to say, okay, FBG for second trial, which is middle wheel at point C. And that's going to become 2 kilonewton. That's positive. So 2 times 0.3125. Okay, plus, then we have the 4 at 6, which is 4 at 6, which is minus 0.625, right? 4 is right here at point C. At point C, that's where influence line is. And the next one is 1.5. It's down here. So we got to find the slope. So it's going to be plus 1.5. And that's a negative slope. Keep that in mind. And the rise is minus 0.625. And the run is 6 feet. 6 meters. 6 meters. And it's gone, we're going from here, come on down, so it's going to be 6, it's going to be 4 meters times 4 meters equals 0, and FBG for the second trial going to come out to, okay, what did I have? I got that. So minus 2.5 kilonewton. Okay. Now let the vehicle keep moving. So if this vehicle moving and it finally gets over here, so the last vehicle, last tire, is at point C. Okay, so that'd be the right here, number 3. The last tire will be on point C. Again, this is going to help us out right here. A little tiny free body diagram so you won't get confused where you are and how you're going to do this. All right. So we said the last wheel is going to be at point C, and that's going to be 2 kilonewton. Then the 4 kilonewton is going to be 3 meters away, so that's a 6. That's going to be 4 kilonewton right here. And the 1.5 is going to be 2 meters away, 9 and 10, 11. So it's going to be right here at 11. And that's going to be 1.5. Now we can go ahead and do the same thing. We're going to say, okay, FBG is equal. Start from the left, it'd be 2 times minus 0.625 because it's right on the money, right on the point right here. And 4, it's over on a slope, so it's going to be 4 times plus 4 times minus 0.625 divided by 6. And how far is it away? It's 3 meters away from the end times 3. And plus, the last one is 1.5. 1.5, and that's time, same thing, minus 0.625 divided by 6 times 1 meter. That's how far away it is. So FBG comes out to minus 2.66. Okay, so the first one came out to this one. Second came out this. So this is the maximum right here. So when the last wheel hit that point C, and that's where the maximum compression force is on this member BG.